So now going back to equation 1.5, this one, right? Let's move on. So that one is equal to this one by conditioning on x, right? And we consider this part and this part separately, okay? So at this point, let us consider the second part, okay, which is this one. And this one says data is given to be C. So data is no longer a random variable. It is a number C. And F data is said to be uniform over data to data plus 1. But data is given to be C. So that one is the distribution is uniform over the interval from C to C plus 1. Okay, so having said that, this conditional probability that data is equal to C, then each one of them, each one of random variables has a non-zero probability whenever these xi is belong to the interval from C to C plus 1. Okay, whenever it is outside of this interval, the probability is 0. Okay, and then this is true for each and every xi. Okay, so that is the evaluation of the second part. That means these dummy variables x1, x2 has to be a value inside this interval. So here is an example. For example, suppose C is equal to 0.5. Then for each I, for each I, xi has to be uniform over this interval. So from 0.5 to 1.5. It has a non-zero probability, and probability density function goes like that. And then outside of this interval, the probability is 0. Okay, so the PDF of this distribution goes like this. Okay. All right. And since the interval is 1, the density function is 1.0 as well. And when you integrate over the whole range of x, basically that is equal to 1. Okay, so it is a distribution. And having said that, we also let n is equal to 3 cases, so that we know what we mean by this expression. Then we consider the following probabilities. All right. So probability, the random vector x has a realization of 1.3, 0.9, 0.7. Is this, what is this? Basically, is it non-zero or 0? As we can see, this one is within the interval. This one is within the interval. All of 3 are within the interval. So this is not equal to 0. What about this one? Aha, this one is outside the interval. So this should be equal to 0. How about this one? 0.8, 0.4, 0.7. Aha, this one is outside the interval. So this should be equal to 0. All right. So that is what we can say about this expression right here. Okay. But again, if we use the rigorous notation, that should be continuous random variable, then we have to treat this way. But the results are the same. Now we understand the result 1.8. So we got the second part. It is 1 if each random variable has the sample within the interval from C to C plus 1. Otherwise, it is 0. Now we consider this one. Okay, that one we will consider. Before we consider that, what I have done here is we apply this 1.8 into 1.7, then 1.7 becomes this. So this the second part is 1 over this interval. It is 0 outside of this interval. So this thing is integration over this n-dimensional vector, and each and every element has a limit from C to C plus 1. Okay, and in such a case, the integrand is not equal to 0. And what's left is this first part. Okay, now we need to evaluate this expression within this interval. We consider this event right here. I have a typo here. This is we are left with the evaluation of the integrand, which is this one. But by the definition of T, which is the X max and X min, but since the order has been switched, we can evaluate this as well. And note that these are given in the starting point. So these are the numbers. C is a number, X max, X min is a number. So only the part that is not determined is X. Okay, so we have to find out those conditions on X that this came out to be non-zero. Okay, and then we only need to consider those parts that this evaluate to be non-zero. Okay, so let us consider that. So this conditional probability shall satisfy the following. So this these are the numbers, and we have to consider these variables, dummy variable x1s, so that this expression makes sense. Okay, so what do we mean by that? So this expression is one. We note that for each xi is a number between x min and x max. Okay, if this is outside of this number, what happens? It does not coincide with this number, right? That is given. Okay. So if xi is a number between x min and x max for each I, then this is 1. Because think about it, right? When x1, x2, xn, so for example, xn is 0.9. Let me see. Just hold on a sec. So I don't think I have written down the example here. So let's suppose that x max is 0.9. X mean is 0.55, for example, right? Then each and every one of them, right? Each and every one of them, I mean, there shouldn't be a number greater than 0.9. All of them has to be smaller than 0.9, right? And at the same time, all of them has to be larger than or equal to 0.55. That way, this makes sense, right? If these numbers is outside of this range, right? Like here, 0.5 and 5 and this one, 0.9. If any one of them is outside of this range, it should be equal to 0, okay? This probability doesn't make sense, right? This probability doesn't hold, right? So this definition is violated, right? It is no longer x max and x mean of these realization. So in such a case, it should be 0. The probability of such case should be 0. And if each one of them satisfy this condition, then by definition, that is the t can be defined as maximum of these numbers and minimum of these numbers. Okay, so that is the key observation. Okay, and that can be summarized with this expression. Now applying this result into the result that we have, result right here. So you apply that right here. We obtain this result. Okay, so it is this expression that x max is maximum of these numbers and x min is minimum of these numbers, and then if these conditions are met, this is 1.0, otherwise it is 0. That means finally it came out to be this. Okay. All right. That is what I mean. I mean, that is the explanation of the result that I have gave in right here. Okay, so denominator is nothing but this, and rest of them you can follow. Okay, so I have explained this example. I noticed that this thing is not easy, but if you try to follow with a careful thinking, and then in order to carefully think about and be consistently following the process that you are developing, I suggest you to write down these equations by yourself and make sure that you understand each and every line that you are making progress.